If you mention climate change, people tend to think about the hole in the ozone layer or the disappearing rainforest. They might think of endangered species, the panda or the tiger. I've got something to show you, Carol. Look at this. This is a Time magazine. They recently had a special report on how climate change is causing a new age of extinction. But of course, on the cover you see it's an endangered land animal, a tiger. No one is talking about the most important animal that's under threat. It doesn't have a cute face. It's a minuscule, unlovable creature called plankton. But pay attention, because what's happening to the plankton in our oceans and to our oceans in general is a sign of what's really happening to us. They are the bedrock of the food chain, trillions of plankton. But in her startling new book, Seasick, The Global Ocean in Crisis, Alana Mitchell reveals that plankton are also the key to the climate change crisis and the whole chemistry of our ocean. Mitchell, who won the award for the best environmental journalist in the world in the year 2000, says we are ignoring what's happening under our water at our peril. You talk about this, the global ocean in crisis. What role does the ocean play? Maybe most of us don't really get it.
No, nobody gets it. Well, scientists get it, but it was a complete surprise to me. I mean, I didn't know any of this before I started on my quest. I never thought about what was happening in the ocean. I didn't understand that it's the ocean that keeps us alive. You and I are here, and so is all other life on the planet.
Tell us why. I don't even understand that. What do you mean by that?
Because the ocean, the creatures in the ocean, specifically the plankton, control the chemistry of our planet. So they produce oxygen, they control the climate, the carbon cycle, they control the nitrogen cycle. They determine the parameters for life on the whole planet.
These little invisible...
These little invisible things. So the way it was put to me by one of the scientists was that if everything on land were to die tomorrow, everything in the ocean would be fine. But if everything in the ocean died tomorrow, everything on land would also die. We're completely, utterly dependent on what's happening in the ocean.
And according to scientists, what's happening in our oceans is unprecedented. If you think that burning all those fossil fuels only affects the air we breathe or the smog we see, think again. Much of that carbon ends up in our oceans, and it's radically transforming the very chemistry of the water. And that's the dirty little secret no one is talking about.
It has to do with carbon dioxide that we're putting into the atmosphere. So when we burn fossilized carbon and carbon dioxide goes up into the atmosphere, about a third of that ancient carbon is absorbed into the global ocean. And when it's absorbed into the ocean, it's chemically reactive. It reacts with ocean water and creates a mild carbonic acid in the ocean. And that is pulling down the pH of the global ocean and making it more acidic.
So the oceans are getting acidic?
Yes.
And what is the consequence of that acidity?
Well, it means that creatures that are used to a certain range of acidity, like say larvae that are vulnerable, aren't going to be able to thrive. They may not be able to reproduce, they may not be able to eat, they won't be able to maintain their own internal chemistry because their surroundings have changed to that degree.
So carbon dioxide emissions in the air, they go to the ocean, they change the acidity, the chemistry of the ocean, they kill off species.
Right.
And then the chain reaction.
Exactly.
And that's scary stuff.
That's a cascade. That's known as a mass extinction.
That's a mass, and you're laughing, but that, you talk about that's the switch of life that could be turned off.
Yes, that's the switch of life.
According to Mitchell, there are already signs that the switch of life is turning off, and you see it in those billions of little plankton. Actually, they store carbon that we emit in their tiny shells. Plankton are kind of like a massive rainforest in the ocean, and to the shock of scientists, this huge lung of the world is in danger of collapsing.
When I spoke to one of the scientists who figured it out, when she realized the implications of this, she ran into the bathroom and threw up.
And what did she realize? What was
she realized that what's at stake in the global ocean is anything that needs to use calcium to build a shell. So that includes plankton that have calcium shells. That includes coral reefs that are the nurseries of life. Every second breath you take is oxygen produced by plankton.
How do they produce the oxygen?
By photosynthesizing, because they're the great plants of the ocean, of the planet. They're the true lungs of the planet.
So there's, we always think, oh, watch out for the Amazon rainforest or the Congo or the Great Boreal Forest are the lungs. But really, there's another set of lungs that are even bigger.
The consequences of, what happens if plankton can't make their shells are, it's an enormous unknown. This is an uncontrolled experiment.
You see the results of this uncontrolled experiment showing up in places like coral. Scientists now estimate that 60% of the world's reefs are at risk due to human-related activities. In the Caribbean, over 80% of the coral has been killed in just the past 30 years. And the southern part of Australia's Great Barrier Reef has also been damaged by ocean change and human activity, and it's not recovered.
Coral are symbionts. They are symbiotic. So they can't feed themselves. They're animals, and they can't feed themselves.
Stop. Some people think they're plants.
I know!
That's so cool.
Yeah.
Coral are animals.
Coral are animals.
These little...
Yeah. And they don't move, right? They just stay there. They're like jellyfish on these big, limestone structures that they build. Yeah. These really, really neat structures.
Beautiful, but you never think of them as animals.
But actually they're animals. And to survive, they need to attract little tiny plankton, again, into their very cells. So the colors that we see when we look at corals are from the algae that live inside the cells of the corals. When the water gets too hot, those little algae that live inside the cells of the corals aren't very happy, and they leave. And that's what bleaching means. So they don't have the plants in them anymore. They're just the coral animals without the plants that give them life.
But if coral bleaching is one sign of the ocean sickness, even more dramatic are what Mitchell calls the blobs. 407 huge dead zones of water with no life in them at all. The cause, the fertilizer we use to grow our crops.
The one I looked at was in the Gulf of Mexico, and they call it the blob. It's one of the best studied. The year I was there, it was 17,000 square kilometers, just in area. That doesn't include the volume. So, and what it is, this is all the farmers up and down the Mississippi River are using chemical fertilizers.
Nitrogen fertilizer.
Nitrogen fertilizer. It runs into the watershed, runs right down the Mississippi, and goes off into the Gulf of Mexico like a big hose. All of this fertilizer. And of course, just the same way that it's food for plants on land, it's food for plants in the water. And so we come back. It keeps fertilizer. So we come back to the plankton again. The plankton go crazy. They just have an absolute orgy, right? They reproduce like nuts. They die, fall to the bottom, and then the second stage takes over, which is all these bacteria start to decompose them. And as they do that, they use up all the oxygen. So that from the bottom, from the seabed up, grows this big blob of water that has little or no oxygen. And of course, if it has little or no oxygen, fish can't live there. Crabs can't live there, all the things,
shrimp,
all that stuff.
Dead.
It's an absolute graveyard. And this thing is 17,000 square kilometers in area.
And if the changing chemistry of the ocean and the pollution were not enough, the industrialized overfishing is another huge threat to life.
It's a very expensive way to get protein, and we're doing it at the risk of further destabilizing the chemistry of the ocean. Roughly a third of the world's population relies on protein from the sea to survive. So if it's not there, the implications of that are huge.
Do you eat fish still?
Very, very rarely.
Really? Like the tuna sandwich?
Never.
Cost is too high?
I think they should be in the ocean.
Straight out.
It's too expensive for our planet for me to be eating fish.
Mitchell believes that new and sustainable forms of fish farming are one possible answer to the food question. But the climate crisis question is even more urgent. Who's ringing the alarm bell outside of you in the scientific community? Why is this not being heard?
What I found is that, things are happening in pieces. It's like a big puzzle that people haven't really put together yet. So some in the scientific community have put it together, and they get it. In England, there's a lot of work on the ocean acidification issue. I mean, they call it climate change's evil twin. The scientists I'm talking to are saying that there may be time to change it. There may be time to slow it down, but it all has to do with CO2 emissions.
I mean, this is not hypothetical alarmism. that the state of the oceans, the data shows that it's doomed if we don't stop?
Stop CO2 emissions. We have to get concentrations, not just emissions, concentrations of CO2 down from where they are now.
So what can people do personally now after reading your book? What's the personal thing they can do?
The last thing I want to do is limit anyone's imagination or creativity on this. All I know is it has to have something to do with carbon dioxide concentrations in the atmosphere, and that we have to bring them down. How we do that, I'm sure there are a million. You can come up with a million better ideas than I can on this, because you're you. And I can come up with ideas that are good for me. And I do take steps in my own life, because I've been scared.
Now, as Alana Mitchell said, and she's scared, the key date here is the Copenhagen Conference, December 6th to December 18th of this year. Now, of course, in 2012, the Kyoto Protocol to prevent climate change runs out. So to keep this process online, there's an urgent need for a new climate protocol, and that's exactly what's going on in Copenhagen. There'll be about 170 different countries represented there. For many people, this is the key conference. Now, the real question in all the issues of climate change is the notion of ocean acidity, exactly what Alana Mitchell's talking about, which she calls the switch of life, and many scientists call the switch of life. Is that on the agenda? The truth is, it's not really on the agenda right now. A sign of hope, though, is that President Barack Obama has actually named a very well-known ecologist named Jane Lubchenco. It's a name that we don't hear much, but you should know. It's an important name as the National Oceanic and Atmospheric Administration, the head of that. She's really the scientist that has pioneered a lot of this ocean acidity science. She's very much on the forefront of this, and she's trying to bring that to the Copenhagen Conference. So the notion that the ocean as a part of the climate change piece, which in England is a big deal, and here in Canada we have scientists that are really on the forefront of this, but putting that more on the public agenda is really the job of this Jane Lubchenco at Copenhagen. So that's what people are watching for.
Why isn't it on the agenda?
Well, again, as Alana Mitchell said, it's scientists work in silos. You know, and you know, in England they've talked about this as climate change's evil twin, as if climate change is not in and of itself evil, of course, but it's just not been one of those things. And I would just say one thing, Carol. I liken it to the kind of the situation of the bison. I took my kids to this zoo, and we saw some bison in the zoo, and it had a sign and it said in the year 1800 there was 60 million bison. By the year 1900, in that technology, there was 1,000 left. We'd wiped them out, and we all think now, how could they have done that? Didn't they see it coming? Well, Alana Mitchell said it's kind of like the ocean. We just don't see what's underneath the surface, and it's what's happening on the Great Plains.
But her point is that it's more crucial to make what's in the ocean survive. Can the coral ever come back?
In the book, in C6, she talks about a study where they've looked to see if coral can come back. And you know what the truth is? They don't know. She does have a wonderful description of how coral actually spawn. They spawn at all over the world, the very same day, the very same hour, the very same minute on the reefs. And the question is, do they spawn enough to grow and come back? And the truth is, they don't know. They just don't know. As she said, it's an uncontrolled experiment.
Says the implications are huge.
Huge implications.